Okay, well, welcome everybody to this evening's webcast with Brian Day from NASA Ames. My name is Andy Shaner here at the Lunar Planetary Institute in Houston. Brian is going to talk to us about ways you can observe and image the moon. This is the second of our webcasts specifically devoted to the International Observe the Moon Night. Currently have a photo contest running for INOM. And later on this evening during the webcast, I'll put a link up to the page where you can learn more about that. Brian's going to tell us about how can you observe and image the moon. And of course, you don't have to have a telescope to observe to observe it. You don't have to have a telescope to image it. So he's going to talk kind of about how these work both ways, which you can do to prep for September 18th, and now Observe the Moon Night. So take it away, Brian.
Thank you very much, Andy, and thank you all for joining us this evening. As has been pointed out, Saturday, September 18th is International Observe the Moon Night, and we do want to encourage you all to observe and, if possible, image the moon. Andy pointed out we do have a lunar imaging contest going, and we have a number of different categories. You don't necessarily have to have a giant telescope to do really nice images of the moon, and we'll take a look at that. So I'm going to try to maximize the presentation right now, and we'll see if that will work for us, and there we go. So the moon is special for a number of reasons, but one of the things that makes it very easy for people to relate to is the fact that it really is the only celestial body that we can appreciate as being another world out in space. Just with the unaided eye, you can see it as a round spherical object. You can make out surface detail. You can see how it moves through the sky. You can see it changing its phase. So because of all this, the moon is something that people can relate to in a way that they can't relate to the other celestial bodies. The other planets people see as, well, if at all, as just points of light. But the moon has something very special about it. Now, as we said, you don't necessarily need a giant telescope to image the moon. You can take very satisfying pictures of the moon with fairly conventional photographic equipment. This is a wonderful picture taken by Rick Baldridge of the moonrise behind Lick Observatory. And one thing that I'll point out is that there are desktop planetarium programs that you can get so that for your location, you can figure out exactly where and when the moon is going to rise or set or be behind certain specific objects in your area. So that'll help you compose really engaging shots such as this one. When looking at the moon, when observing the moon through a telescope, one of the tricks that you will quickly discover is that it is best to view near the terminator, that is the line between day and night. So if you look at this picture here, and I'm going to grab a pointer here, you can see that along this area here of the terminator, the sunlight is coming in at nearly a horizontal angle. And so every little bump, every little hill casts a shadow and stands out in great detail. But as we get away from the terminator, the sun's angle gets higher and higher, and the lighting gets flatter and flatter, and we start losing all that detail. So really, the terminator is a great place to do a lot of your observing. And when you're looking along the terminator, you'll be able to see some of these very subtle relief features. One example here, great example, this is Hadley Rill. Let's see if I can bring that up again. Okay, my pointer does not seem to be working anymore. So in the left picture, you can see what looks to be an arcuate valley, and that is, there we go, that is Hadley Rill. That's an ancient lava channel. The right-hand picture We can see a number of features. Of course, craters and mountains stand out in great detail. You will also see in the upper right corner of the right-hand picture what we call a wrinkle ridge, which is sometimes referred to as Dorsey. Again, you will only see these when they are near the terminator, because these are actually very low profile. Also, in the center of that picture, you can make out some lunar domes, and these are actually lunar shield volcanoes. People look at the surface of the moon, even with your naked eye, you can see the mare, the seas of the moon, those dark lava plains. Well, where does that lava come from? It comes from very subtle volcanoes such as this. And again, you need to look along the terminator in order to see them. Okay. Because the terminator gives you such good views, most people really stay away from viewing the full moon. But there's still quite a bit to be seen during the full moon. First of all, unless you're viewing during a lunar eclipse, even a full moon will have some terminator. So if we take a look here at the, looks like the bottom of the picture curving up toward the right, you can see actually a little bit of terminator detail. You're catching a little bit of shadow features in craters there. But even more so, when you're looking at the full moon, this is a time when you'll see albedo features, the real difference between the light and dark areas. This is best seen under the full light, under the overhead lighting that is provided by the full moon. If you take a look in the below and left of center, we have the crater Tycho, and you can see the spray of material, the crater rays spraying out from Tycho across large amounts of area of the moon. You can see some other craters above that, Copernicus, Aristarchus, also have their ray patterns coming out. So viewing these albedo features is best done during the full moon. Another trick to keep in mind is the concept of lunar libration. Because of the fact that the moon orbits around the Earth in an ellipse and not a circle, and because that orbit is actually tilted relative to us, that means that we actually are able to periodically kind of peek around the edge of the moon. You normally think of the moon as always showing the same face to us. That's almost true, but it wobbles a little bit. And so as a result, we're able to see about 59% of the moon over time. So if you look in various astronomical magazines or websites, you can find out how the moon will wobble, will be tilted, what the angle is of this libration, and so you can take advantage of that to kind of peek around the corner of the moon and see features that normally aren't visible. Another especially exciting viewing and imaging adventure comes during total lunar eclipse, when the moon passes through the Earth's shadow. Now these can be quite challenging because, well, a lot of times people want to know, well, what exposure should I use for getting a lunar eclipse? And there's no simple answer to that, because that reddish hue that you see on the moon during totality, that is light from the sun that is scattered through our atmosphere and then shining on the moon. It's just kind of like when you look at the horizon just after sunset and you see that red glow. Well, that's what they're seeing all around the edge of the Earth on the moon during a total lunar eclipse. But the amount of light that is transmitted through our atmosphere is very variable. So a lunar eclipse might be exceptionally dark. The moon could almost disappear if the atmosphere on the moon or on the Earth is particularly dense and opaque. If there's been a lot of volcanic activity, that can translate into a very deep color on the moon. So if a lot of volcanic activity on the Earth can lead to an opaque atmosphere on the Earth and a very dark lunar eclipse. Each lunar eclipse is different. Fortunately, you'll be able to explore this yourself. Coming up this December, we have a beautiful total lunar eclipse scheduled. So again, this is something that you'll want to keep watching the MyMoon website and the Observe the Moon Night website. Observe the Moon Night website is not just for one night. We are going to keep posting updates as interesting things happen with the moon, and one of them will certainly be this beautiful eclipse of the moon, total eclipse. As you see here from this image, the continent of North America is going to be especially well placed for viewing. All of the eclipse will be visible from North America, weather permitting. As we progress through South America and Europe, parts of the eclipse will be visible. The same thing for Eastern Asia. Central Asia and much of Africa will see no eclipse at all. But this will be an excellent opportunity to do observation and imaging of the moon in a very, very special circumstance. Now, when imaging the moon, this is a good example of a fairly typical result of taking a picture of the moon through a telescope. You can see a number of craters here. If you look down toward the south end of the moon there, you can see the edge is jagged from, those are actually mountains seen in profile. But looking at this picture, it just doesn't seem really sharp. You just want to reach out and grab that focus knob and twist it. But the fact of the matter is, this is as good as we could get it that night. What's happening here is turbulence in the Earth's atmosphere prevents us from getting a truly sharp image. That's the whole reason why Hubble was sent up above the Earth's atmosphere. So looking at the moon through a telescope, you will see that shimmering, wavering image caused by our atmosphere. That can be a problem, but there are ways around it. Here's another example of an image taken by an amateur astronomer. Damian Peach is doing just some phenomenal work, and there's a really interesting technique used. What amateur astronomers who do high-resolution lunar photography will do is they will use a video camera, and there's special video cameras available for astronomy that will adapt right to your telescope. And the reason behind using a video camera is that as you look at the moon, you will see brief instances of really steady viewing. Now, they don't happen all that often, oftentimes, and shooting off your shutter just during that instant can be problematic. But if you've got a video camera going, it can take a whole stream of images. And then at the end of your session, you can go through, and there's even software that will do this for you, and it will select the best frames. Now, any camera, including a video camera, will have a certain amount of noise in it. And if you just take a frame, taken even in one of those really clear situations, and you start sharpening it, you bring it into your photo processing software and you start sharpening it, that noise will get sharpened, and it'll become quite annoying quite quickly. But again, if you're using a video camera, what you can do is you can select multiple frames, select the best frames that you have, and then you stack them onto each other. Registering them and stacking them onto each other means that the noise, which is random, will tend to cancel out. But the signal, a picture of a mountain, will remain in the same place from frame to frame to frame, and so that will reinforce. So your signal to noise ratio as you stack multiple frames will become significantly greater. Then when you use a sharpening algorithm, you can get amazing pictures such as this. Magnificent work being done by Damian and by others using this technique. Now, a lot of times the sensors on these video cameras aren't as big as, say, the sensor on a digital single-lens reflex camera. But what you can do is you can create mosaics, and as a result, you get pictures that really look like they were taken from in lunar orbit rather than from here on the Earth. Got some good examples here. If you go to Damian's website, you can see just the amazing work that's being done. Digital processing comes in a number of areas. Here's a picture of the moon taken, well, this is full color. And you know, when you look at the moon through a telescope, you pretty much see the moon in shades of gray. Now, there are experienced lunar observers who will tell you that there are actually subtle hues there, and they will talk about browns and greens and reds and blues. Yeah, I've spent a lot of time looking at the moon, and I guess I'm just not that sensitive to it. But in fact, the colors really are there. They are just very, very subtle. And with digital processing, we can enhance those colors. And the result, taking the same image and enhancing the colors, is this. Notice the coloration, different coloration in the seas, the greens, the blues, showing different areas of different times of lava flows, different times of eruptions on the lava flows, different mineralogies. So the different minerals show up in different colors. If this is showing up well at all on your screen, you're seeing some hints of red, a lot of blue, some green, some yellow. And again, this is mineralogy, different minerals showing up in different colors. Very, very spectacular. Now, there's some tricks to doing this. This was taken with a digital single-lens reflex camera through a telescope. Nothing entirely special. But if you just take the picture that you've taken with your single-lens reflex camera and put it into your image processing software and crank up the color saturation, this is not what you're going to see. It turns out digital cameras typically are set for certain white balances. Sunny day, fluorescent lights, whatever. And those will have certain color biases. So as you crank up the color saturation, what you'll see is you'll get all of a sudden a deep blue moon or a deep yellow moon or whatever. The bias that is in your white balance will be emphasized. So the first thing you have to do in your digital image processing software is to normalize the red, green, and blue color channels. Make them as identical as possible. Then you can start stepping up the color saturation. And in doing so, remember that multiple small steps tend to work better than one big step. So do an iterative process. Now, as you increase your color saturation, one of the things you're going to see is that noise in your image is going to become very, very evident and very, very annoying real quick. Don't worry about it. You'll get a grainy looking image. The color will enhance, but it's going to look like really rough sandpaper. That's okay. We'll fix that. Once you've got the color saturation, ignoring all that noise, once you've got the color saturation to where you want it, then again, using your software, you want to take and break your image into the different layers. You'll have 2 layers of color, 1 layer of luminance. You can apply a gentle blur to your color layers, and that can help. But the main thing to understand is that while the color detail is in those 2 layers, the luminance is actually showing all the image detail. All 3 of those layers are going to look really, really grainy. But if you go back to your original image of the moon, copy that, and then paste it into your luminance layer, then what that means is you will have the original sharpness and relative freedom from noise of your original low contrast or low saturation image, but you will have the enhanced color from your 2 color layers. So it's a little bit of trickery, but it ends up working very well. Another really fun thing to do in observing and imaging the moon is watching for Earth orbit satellites passing in front of the moon. And there's actually a wonderful website you can go to, calsky.com. They'll provide free predictions for your location. So it'll tell you when something like, in this case, the International Space Station is going to fly by. So this picture by Ed Morana in California is just phenomenal. He knew when and where to point his telescope, again using a video camera because space station goes across the disk of the moon very, very fast. Oftentimes in less than half a second, it'll make its complete transit. So being ready on a cable release on a camera is problematic. But having a video camera running, grabbing frames many times a second, that's the type of thing that can result in this. And Ed's got some wonderful pictures on his website that I'm listing here. But again, what you can do is register your location, and you'll get advances or alerts in advance as to when and where to look for exciting events such as this. Continuing on into more advanced areas, if you really want to get into the area of lunar research, you can get into the field of searching for transient lunar phenomena. As long as people have been looking at the moon through telescopes, there have been reports of sudden brightenings that might last for a few seconds to a few hours. Brightenings, sometimes darkenings, sometimes changes in color. There's been some debate for a long time as to whether these were actually happening, but now a lot of researchers, I'd say the majority of researchers, are beginning to come to the opinion that these really are real phenomena. They are not well understood, but they do seem to correlate very well with areas that are perhaps associated with outgassing on the moon. One of the things we see from the pictures from LRO is we're gaining an understanding that the moon may not be the geologically inactive area that many of us had thought that it was. That there may be still some really interesting relic activity going on. And as a result, there are active campaigns among amateur astronomers to actually observe and record these types of events. So this is an area where you can get into real, actual lunar research. Continuing along those lines, there's another program operated by NASA's Meteoroid Environment Office, and I'm listing the URL here, to actually watch for meteoroid impacts on the moon. Typically what we'll do is we'll look at the dark portion of the moon, because that's where those flashes will show up best. Here you can see an image by amateur astronomer George Varos, and I'm going to try and grab my pointer again, and that's not working for me. So Andy, if you can grab the pointer and bring it to the little dot there, you can see it. Yes, so that is a flash from a meteoroid impact on the moon. And this is actually of great scientific interest to us now, because for one thing, we know that the moon does indeed have a very thin atmosphere, something that is most properly referred to as a surface boundary exosphere. And impacts such as these could be an important source for that atmosphere. So one of the things that we are trying to get a handle on is a better estimate as to the flux, as to the rate of these impacts. And so this is a opportunity for amateur astronomers to get involved with NASA in doing, again, real lunar research. And this can be done with telescopes as small as 8 inches in aperture. And here's another interesting picture. You can see in the upper left there another impact flash. These are actually surprisingly common. If you go to the website, the Meteoroid Environment Office, you'll see they are categorizing, they're listing a number of these happening surprisingly frequently. So this is something that is an exciting thing to look for, especially looking during, say, the course of a meteor shower. That can be especially interesting. And finally, taking it to the limits. I mentioned before that the moon does indeed have a very, very, very thin atmosphere. Surprisingly enough, though, this atmosphere glows. It glows primarily in the light of fluorescing sodium atoms. But again, because the moon's atmosphere or exosphere is so very thin, it's not something that you would just look up in the sky and see. However, it does glow bright enough, interestingly, that if you could take that big old bright moon magically away and just have the atmosphere remain. That atmosphere glows brightly enough that in a very dark sky, you would just be able to make it out with dark adapted naked eye. It's actually that bright. Of course, we don't see it because, well, we do have that big bright moon right there next to it. Professional astronomers here on Earth have been able to image the exosphere of the moon here, as you see in this picture. It's typically done with very narrow band filters and an optical arrangement known as a coronagraph. To date, the only pictures of the lunar exosphere have come from professionals. But I feel confident that at some point, as the technology advances, perhaps sometime very soon, we will see the first image of the lunar exosphere from the amateur community. Who's going to take that picture? We don't know. But that will herald in a very exciting time. Because when that happens, when the technology advances to that point that we are able to do that, that means we will be able to much more closely monitor the lunar exosphere, see how it responds to changes in solar cycle or things such as meteor showers. This is a very, very interesting area for future development. So keep your eyes open here. The bottom line in this is that from sightseeing to artistry, pushing the limits of technology, participating in lunar research, observing the moon has opportunities for all levels of sky watchers. So whether you're just starting out or whether you want to make contributions to lunar science, there is something for you to do in this area. So I encourage you all to participate, and a great time to do that will be this coming Saturday, September 18th, International Observe the Moon Night. So with that, I will attempt to answer your questions, and we're going to minimize down the presentation screen, and let's see what we have to work with.
Brian, if you could do me a favor and mute your mic when I jump on, just because it seems like remember we're getting some kind of repetition from me with both our mics open.
Okay. I've done so.
Go ahead and hit the talk button again. There we go. Okay. Okay. Yeah, so like Brian said, he'll take any questions you have them. If you have them, we'd like you to type them there in that box on the right where it says Ask Questions Here. I see a lot of folks have jumped on since we got going. If you just want to chat or say hi there in the right or in the box on the left, you're more than welcome to. But if you've got a question, go ahead and type it there in the right. And I'll go ahead and we got one, somebody typing one right now, but I'll go ahead and ask one that was sent to us earlier. Somebody was asking, Brian, do you have any suggestions for middle school level moon observing projects that work well with the Galileo scope? Maybe you might want to describe what the Galileo scope is in case you folks don't know. You're not able to press that talk button?
Let's try that. Okay, now if I hold it down, how about this? Are you hearing me? Okay, so it looks like I'm going to have to hold it down now. Okay, so yes, first of all, the Galileo scope. This is something that came out of the International Year of Astronomy, and this is a wonderful kit to put together a very small, simple refractor telescope. It's something that classrooms across the country have done. It's really, really a lot of fun. But with this small, easy-to-assemble telescope, you can actually see detail on the surface of the moon. You can make out the lunar seas. You can make out the craters. It's a really fun project to do. So, once you've assembled the telescope, what are you going to do with it? One thing I would suggest would be use that telescope to actually do some sketches of detail on the moon and see how the detail of the moon seems to change night by night. Now, for years, well before photography, people were recording the detail on the surface of the moon through sketching. And one of the things that happens is when you are sketching detail on the moon, that really trains your eye and gets you seeing detail on the moon that you might miss in your first cursory glance. So it's a really good way to train your eye, to bring yourself to see surface details, and to record these wonderful things and see how they change night by night as the phase of the moon changes. That's one suggestion.
Okay. Then we have our first question up there asked, what is the best method to capture the entire moon disk into the sensor chip of an attached webcam, CCD or COMS camera?
Again, that's going to depend on your sensor size. So, for instance, some of the CMOS chips that are in digital single lens reflex cameras are going to be significantly larger than, say, the chip in a webcam. Typically what you will do is you will match your sensor to the focal length of the telescope you are using. Full disk of the moon will require, so a lot of these pictures that I took here, I was using a CCD or a CMOS chip in a digital single lens reflex camera, and I was using a 114 millimeter aperture refractor with a focal length of about 500 to 600 millimeters. If you're going for the full disk of the moon, you will want to use a very short focal length compared to what you would use for the surface detail going in for individual craters. But experiment, pair your detector with a variety of telescopes of optical configurations. But especially when you're using something small like a webcam, you'd be amazed the quality of images that can come from webcams. People are doing amazing lunar imagery with webcams, but because those chips are so small, you're going to want to use a very short focal length on optical configuration.
Okay. And the second question was asking if this presentation will be available after the show. Yes, we're recording this presentation, and as soon as the good folks at NASA Ames move the recording over to my particular folder on this program, we will post it on the International Observe the Moon Night website. And I put that link up there in the chat box on the left. It's the second link that I posted. That's the particular page this recording will be on. It'll be down towards the bottom of that page. So as soon as we get that recording link sent to us, we'll post it up there. So hopefully by the end of this week. Another question we had sent to us ahead of time, Brian, kind of goes more towards possible future human missions, but what experiments would you like to see performed by next humans on the moon? Need your mic, Brian. Sorry.
Let's try that again. Yeah, I do have to hold it down now. Having been involved with the LCROSS mission, I am particularly fascinated by those deposits of water ice at the poles of the moon. And, at some point we're going to have to get our hands wet. So actually getting some of that ice and really being able to do a thorough chemical analysis is especially interesting. There are utilitarian reasons for wanting to get at that ice. If we're going to be living and working on the moon, that's a great resource. But another reason is because of the scientific value. I think here on Earth, we have scientists who go to the polar ice caps and who drill cores down into those ice caps to bring samples up that tell us the history of centuries of what's been going on in our environment. And look back for centuries. But on the moon, these permanently shadowed craters have been gathering ice for perhaps billions of years. These are the dusty attics of our solar system. And so by sampling this material, we can study the environment of the inner solar system and how it has changed over billions of years of time. That's important because remember, our environment doesn't end with our atmosphere. We are all residents of the inner solar system, subject to solar storms, meteor showers, whatever, changes in solar activity. And so getting a handle on how the environment of the inner solar system has changed, that's important, and that's something that perhaps we can gain by studying these deposits at the poles.
Thanks, Brian. Rob has his hand raised. Do you have your mic up, Rob, to ask a question?
Hello, guys. This is Rob Cowan from A Sky Full of Stars. Great talk. Unfortunately, I could not hear the whole thing. But to your last point regarding ice on the moon, if we do these core samples, if we study these dusty craters, will this lead us to understanding where all the water came from on this planet? What scientific benefit? You talk about utilitarian benefit. What kind of scientific benefit in terms of the genesis of the planet that we live on right now will this bring?
Very good question. Thank you for that, Rob. Yes, as a matter of fact, that is one of the goals. We currently believe that much of the water that came from the Earth didn't form here with the Earth. That is, the region where the Earth formed in the inner solar system is a pretty warm area, and during the early phases of the solar system, this is where we would have expected the more refractory elements and compounds to have come together. More volatile compounds like, well, water, probably would have condensed much further out in the solar nebula. So then the question is, how did that water get here? Possibly delivery through comets. But these are all theories. This is all theoretical discussion. And so what we would really like to do would be an isotopic analysis of that water. And that can give our lunar scientists and our planetary scientists a really good clue as to where that water came from within that pre-solar nebula.
Right. Good question. Paul asked, what video camera would you recommend for recording lunar images?
You know, there are a number of brands out there, and I am reticent to recommend one brand over the other, but what I would do is, and plus there are new models coming out all the time, so what I would do is recommend going to websites like Damien's. You'll see a number of people out there who are doing this using video cameras. And take a look at the work they are doing, take a look at the cameras they are using, and especially look for people that have optical configurations that may be similar to yours. So if they're using a 10-inch Newtonian reflector, which is what you happen to have, then take a look and see what kind of camera they are using. But again, this is a rapidly changing area. Keep an eye on the popular amateur astronomy magazines. You will see new cameras being announced and reviewed there all the time.
Oh, I'm sorry, go ahead.
Hi, people. I'm sorry, do you hear me? Oh, well, my alias is Spock. I'm Carlos Quintana from Caracas, Venezuela. And I'd like to know, Mr. Day, if the famous moon hoax, is it going to be considered during this activity, or maybe, mm, you know, we could talk about that with the people observing the moon, etc., to illuminate them about this famous hoax. Thank you.
So I'm assuming when you're talking about the moon hoax, you're talking about the uh, discussion that perhaps we did not go to the moon. We did not land on the moon. And one of the wonderful things that has happened lately has been this fantastic mission called LRO, the Lunar Reconnaissance Orbiter. And for years, I mean, I ran an observatory for years, and people would always ask me, well, can we see the flag that was left behind? And well, no, there's no telescope on Earth that can show the flag. And that kind of, you know, fed into that controversy, that conspiracy theory. Well, now finally we do have that tool. So with the Lunar Reconnaissance Orbiter and the images that are coming back, we can see the hardware that got left behind. We can see the flag. We can even see the footprints. This is wonderful stuff. So that's a really good time to bring up the imagery that's coming back from Lunar Reconnaissance Orbiter as you're engaging the public on Observe the Moon Night. And the wonderful thing about Lunar Reconnaissance Orbiter is this imagery is being made available to public all over the world. So as it comes down, you can observe it. You can actually use the MoonZoo software to help characterize the surface features that we are seeing on the moon. So I am hoping that now that we are able to actually see the moon in this detail, that we will be able to help put that hoax to bed. Thank you for the question.
Yes, thank you, Mr. Day, for your kind answer. And as I heard you, I was reading too from Nicaragua, Jay Vanini. He plans to show videos from the Kaguya mission and picture from the LRO showing the lunar landing sites, as I can read. So I think it's a good opportunity to educate people and to demystify this entire hoax, because there are new generations that do not know that we landed on the moon, that they need to be re-educated because of the internet influence is widespread, doing this kind of things of hoaxes, even the Mars hoax too, etc. So I hope we can do some contribution with the people who is going to observe the moon next September.
Thank you. You've raised excellent points, and now with this constellation of recent probes that have returned to the moon, we can now finally provide you with the tools you need to address these issues. So thank you.
Yes, thank you for jumping on. I think this is the first webcast we've ever had through MyMoon where we had international people jump on. So that's really awesome. We're really glad to see you all with us here tonight. We had a question come up here from Leslie asking, what are some of the other types of atoms besides sodium in the atmosphere of the moon?
Well, that is a particularly excellent question, and that is a question that we are going to try to answer with an upcoming mission called LADEE, the Lunar Atmosphere and Dust Environment Explorer. When we image the lunar exosphere from here on Earth, we see predominantly that light from glowing sodium atoms, but we are very confident that sodium is actually a relatively minor constituent of the lunar exosphere. So what else is there? One of the things that, of course, would come to mind now, after what we have discovered with LCROSS, as well as the spectral information that came from the Chandrayaan probe, is that we might expect to see water vapor in the lunar atmosphere. There are a number of hydrocarbons that we might expect to see. There are quite a few potential elements, but to really do this, we're going to have to get into the atmosphere and sample it. And that's the goal of the LADEE mission. It's scheduled to launch in early 2013, and it will go into an orbit around the moon, and it will dip down low and actually into this lunar exosphere, and it will collect samples that we will then be able to analyze and find out just what that atmosphere is made of, how it varies over time and over altitude, and also see if there is in fact an active dust component in that atmosphere. So it's a great question. It's a question we are looking forward to answering, and we think we have a really cool tool to answer that question. Stay tuned.
Great. Hey, Brian. Anybody else have any questions? We have a few more that we got, but let's see if anybody else wants to jump in first of all. Looks like Matthew has a question. Go ahead, Matthew.
Is for Andrew. You said that you were in the Houston area, correct? Okay, I'm currently a USRP intern at Johnson Space Center, and I'm very interested in any sort of outreach programs you have available. Do you think it'd be possible to maybe set up a meeting of all the co-ops and interns at JSC at
Sorry, Matthew, I didn't catch that last part. I heard something about maybe setting up a meeting with the interns at JSC. Was that your question? That might be possible. What I would recommend is, I'm sure you probably know who Anthony Zippe is. Zippe, he's the USRP coordinator here in Houston. You get a hold of him and see what he thinks, and if he'd like to get together with us here on LP, what we do specifically here at LPI, that'd be great. But I'd go through Anthony first with that question. But that's a great idea. I'm certain that's something we can certainly look into. So we've got a couple of folks typing something in there. In the meantime, Brian, I got a question for you. Do you have your own particular favorite feature on the moon that you like to look at, or that you like to image?
Yes, that is a great question. For me, one of the most challenging things that I enjoy looking for are the lunar domes. So these are the lunar volcanoes that are these low, broad shield volcanoes. And again, the lighting has to be just right to pick them out. You want them to be very near that terminator. You know, it's a question that so many people have asked for so long. If we see these vast fields of lava on the moon in terms of the seas, but you know, if you've got all that lava, where are the volcanoes? You don't see any Mount Rainiers on the moon. But there's reason for this. It looks like a lot of the lava on the moon tends to be a very, very non-viscous form of basalt when it was erupted. And when I say non-viscous, I mean very, very runny. In many cases, probably about the same viscosity as olive oil at room temperature. And so, as a result, it tended not to pile up, but flow out over broad areas. And so, most of the volcanoes on the moon take this very low, subtle shield form. Now, there are, of course, exceptions to the rule. And if, again, you take a look at the LRO website, you will see that there are some wonderful images and discussions of the Gruithuisen domes. And these appear to be volcanoes on the lunar surface that involved a thicker, more viscous form of lava, and they show up much more easily. But for sheer challenge, going after these low relief lunar domes, that's a lot of fun.
Cool. Next one up there is Scott asks, are images taken by the Lunar Reconnaissance Orbiter showing previous landing sites publicly available?
Absolutely, yes they are. And so I strongly recommend that you go to the Lunar Reconnaissance Orbiter website, and they have an ever-growing archive of amazing, amazing pictures. Also, again, they are feeding those images, or those images are being used by the Moonzoo program, where you can help characterize the lunar landforms. But specifically, if you're looking for the lunar landing sites, then yes, those images are definitely posted on the LRO website.
Marcelo just sent me a disturbing question. Since I actually manage the INOM website, yeah, that's not right. That shouldn't. You should definitely be able to see that. There's no reason you shouldn't be able to. I will talk to our IT folks about it tomorrow. See what they know. Marcelo, any information you could send me about, like, when you try to look at the site, what kind of display, what kind of message do you get on the web? Anything you could help out, anything you might be able to tell me would be great. I can pass on our IT guys. Maybe they can figure out what that is. But that's not good. We don't like to hear that. So we'll look into that. Thank you.
I do see the remark from Venezuela that they are seeing it find in Venezuela, so that's some reassurance. But yes, we do, since this is an international event, we do want to make sure that all of our international partners are able to see this information.
Todd asks, should we be as concerned for a large asteroid impact on the moon as one on the Earth?
Should we be as concerned? Probably not, because we have a lot more people living on the Earth than we do on the moon. So the Earth is actually a much larger target. It's got more gravitational pull. I, quite frankly, would probably very much enjoy seeing a meteoroid impact on the moon. They actually happen relatively frequently, but a large one, no. But something the size of L-Cross, that type of impact probably happens multiple times a month. The thing that was different with L-Cross is we knew in advance when and where to look, whereas typically it's a matter of being surprised and looking for lunar impacts.
Francine asks, where on the moon should we look for the lunar domes?
Where on the moon should you look for the lunar domes? There are lunar domes scattered across the face of the moon, and there are actually some wonderful websites, and if you get lunar atlases, you can get some good maps that will direct you to them. But let me give you a couple of hints right offhand. If you look just south of the crater Aristarchus, there is a wonderful field of lunar domes called the Marius Hills. And again, the Marius Hills are something that you need to have that terminator right in that area. But a beautiful field of lunar domes, as well as rills or collapsed lava tubes, lava channels. Very, very interesting area. Another area to look at is the region immediately surrounding the craters Hortensius and Militius. I'm probably mispronouncing those terribly. And And then a really spectacular area is you're looking toward, I would guess it would be on the northwest area of the moon using the lunar nomenclature. But in the area of Oceanus Procellarum, there's a great complex of domes called Rumker, R-U-M-K-E-R, umlauts over the U. And this is a wonderful area to watch, especially if you watch, say, during the lunar sunrise there, and watch that sunrise play across those domes in that upper area of Oceanus Procellarum. The Rumker domes are really spectacular.
Thank you, Brian. Really quick, I want to just Marcelo, if you can, if you see there in the chat box, I put the link that actually will take you to the information for this webcast for this evening. And on that particular page is a comment box. If you could fill out the information on that page, that email will come to me and just remind me that you're having problems in Brazil. That way I'll have your email, and then we can see what we can figure out, let you know what we find out. Sky Full of Stars asks, will we have a listing of Moon Webcast September 18th? Have people registered the way that we were registering for local events? Brian, do you want to take that? I can. No, need your mic, Brian.
Hi.
Sorry, let's try that again. Yes, we are going to have a webcast originating out of several locations, including Goddard Space Flight Center, the Lunar Planetary Institute, and NASA Ames. And there will, I believe, Andy, be a posting on the International Observe the Moon website detailing these. Is that correct?
Yeah, we currently have the information about the talk, the times, presenters, and topics. We don't have the link yet. We're still working on how we're going to get that, exactly how that'll work. But as soon as we get that link up, we will have it on that page. It's actually the same page that we'll post the link to the recording from tonight's webcast. It'll be on that same page. You'll see actually on top of that page, you'll see the information for those different webcasts. If other institutions besides LPI, Ames, or Goddard will be broadcasting them as well, that would be good to know. And we can certainly, if you have a link for those, we can certainly put those up. And I'm just trying to think how you could get that to us. You know what? Let me just give you my email address here in the chat box. And if you are going to be at a place, or if somebody you know, an institute you know is going to be having something where they'll be streaming presentations, if you want to send me that link, I'll be more than happy to put those up on that website.
It's probably important to note that one of our partners in this endeavor of International Observe the Moon Night is Astronomers Without Borders, an international group of amateur astronomers. And I do understand that a number of them will be doing webcasts from their locations. And so we look forward to getting that information and sharing it with our audience worldwide.
Okay. Anybody have any questions? Any more? Looks like maybe we've gone a little quiet there. Maybe looks like maybe Adam might be.
Well, here
Yes.
spoke again. Well, Carlos again. Mr. Shaner or Mr. Day, will you have a webcast after this event? I mean, a few days later, a week later, something like that, or just during the event itself?
I think, well, if you mean like a webcast like we're having tonight and like what we had last week, we don't have any of those planned. But if you mean more just kind of other talks, like what we'll see on INOM, those I'm not sure. But these webcasts that we're doing like tonight, we do about every other week through the Lunar Planetary Institute, through our MyMoon website. Some presentations are like this one tonight. We have somebody come and talk about more about the science of the moon. Sometimes we have some folks come on and talk about maybe they may be artists and talk about how the moon has influenced their work or how they use the moon in their work. We had the poet laureate of South Carolina talking about the moon and poetry. It's all kinds of different things. We're trying to not only present the lunar science and exploration, but we're also trying to present how the moon is influential in other aspects of culture, in terms of the arts as well. So these webcasts we do, like I said, about every other week. We try to schedule them. So just keep checking the MyMoon website, which is, I'll put that link up there in the chat box for you.
Okay, thank you. I'll be looking for that then. Well, I hope we all have clear skies and we can enjoy a very nice show from the moon. Thank you very much.
Thank you. One of the things too that I'm seeing some of the chat going on here. Again, if you can attach a sensor, a detector, even a webcam to your telescope, and then if you want to stream images from that night, we have a number of people who are expressing interest in doing that. There are, of course, a number of services on the web where you can post live video streams. And so if you are planning to do that, again, please let us know. Those are things that we will be very, very interested in sharing with our worldwide audience.
And Skyfall started asked again. Okay, he's asking. Okay, if folks are going to be streaming their views through a telescope on the 18th, and we just want to get, I guess you're saying if they can get their link out there. If you wanted to, when they register, like the way we have it on the INOM site right now, unfortunately, there's a lot of things we would love to do with the website this year that we just couldn't do because basically we just didn't have the funding. I mean, we're fortunate that our RT folks are pretty good. They could get what they did get done with the money we had available this year to do it. If you wanted to, when they go and register, and of course I know a lot of people have already done this, but if they want to register, and there's an option where you can put a link to maybe to your your event, that would be a place where you could put a link where you know that you will be streaming from. Otherwise, again, we can just add it to that, to also the page where we're going to list presentations. We can certainly put them on that page as well. We have no problem doing that. So we have one more question here, and we'll wrap it up with this question. We're starting to hit that hour mark. Adam asks, does the moon have tectonic plates, and are these plates responsible for moonquakes?
So the best answer that we have right now is no, the moon does not have tectonic plates. So the concept of continental drift that we have here on Earth does not seem to apply to the moon. So what might cause moonquakes? A number of cases. Those are probably caused by impact phenomena. But if you look at some of the recent discussions coming out about results from LRO, you can see examples of certain types of fault scarps that indicate shrinking of the moon. And so again, perhaps there is some form of geologic activity that is still going on. That's a possibility. But one of the wonderful things about the fact that the moon does not have the plate tectonics that we have here on Earth means that the moon itself could have rocks on its surface that are far, far older than those here on Earth. Rocks tell planetary scientists stories of the time that they formed. But if we want to find rocks that tell of the earliest times on Earth and the formation of the Earth, well, those rocks just don't exist anywhere on the surface of the Earth anymore. Plate tectonics has recycled the surface of the Earth. But on the moon, where we don't have those plate tectonics, we could have rocks that go back to those earliest of times. So actually, because we do believe that the Earth and Moon formed together, interestingly, if you really want to know about early days of the Earth, perhaps the best place to go is the Moon.
I would second that, Brian. I think a lot of, not most or all, of the scientists in the neuroscience community would agree with you that the best place to learn about the early Earth is on the Moon. Hey, Rob, we're going to let you get in the last little bit here, and then we need to wrap this up for the evening. Rob, please.
Gentlemen, and this has been very informative. This is Rob Cowan from Sky Full of Stars. Last question was a question on the status of the, I guess they called it a mini magnetic field that had been imaged. Remember it back in April. A small, I think it was described as an umbrella of minimally protective refuge from solar wind. Has any further verification or understanding of that miniature magnetic field taken place?
I do remember reading about that. There are areas of relic magnetic field on the Moon, much less strong than there are here on the Earth. I do not know what the current status is on research of this area, but I'm sure this is going to be an area that will be investigated with great interest, because this is areas where essentially have frozen in the rock magnetic field perhaps a long time ago. But I'm sorry, I just honestly do not know latest on that research. Andy, do you have any further information on that?
I sure don't. I do remember that, though. That was really interesting, but I haven't heard much, haven't heard anything here about that either.
One of the exciting, though perhaps frustrating things that has come about is that the field of lunar science is suddenly becoming far more rich than it has been for a long, long time. Seems like after the Apollo era, the Moon was largely forgotten. We had a couple of adventures with Lunar Prospector and Clementine, but the Moon actually was being ignored by and large for quite a bit. And we are now in the midst of a very, very, very exciting time, with missions being sent to the Moon from a number of nations, and collaborations with instrumentation on spacecraft from a number of nations. And so now all of a sudden we see this explosion of information coming from the Moon. And it's actually getting to be pretty hard to keep up with. A number of articles that are coming out are dramatic. And that's a good thing, but again, it can be a little frustrating trying to keep up with it.
Yeah. I actually came from a Mars background. In graduate school, I worked for the Phoenix Mars mission at the University of Arizona. So when I came to LPI, and all of a sudden they've thrown me into the deep end with the Moon, it was quite a shock. But it's been great, and really, when you start to learn more about the Moon, you really realize how it helps you understand the whole solar system. About what we can learn from the whole solar system just from the Moon. So one thing I know because of learning more about the Moon, I have started to view the solar system more as a whole piece instead of individual planets. So it's studying and learning more about the Moon is really, really fascinating and really great. So we need to wrap this up for the evening. We told Brian it wouldn't go much longer than an hour. It's just a little bit over, so sorry about that, Brian. But I want to thank you all for joining us. This was some great questions and great conversations tonight. This is wonderful. Like I mentioned earlier, we will have a link to the recording of this webcast if maybe you missed the beginning or you want to watch part of it again or share it with somebody else. Hopefully we'll have that link up by the end of the week. It'll be on the International Observe the Moon Night website. If you scroll up in that chat box on the left, you'll see I posted a link there earlier to it, to the page, the specific page it'll be on. And it all depends on when the good folks at Ames can get that link to me. But we'll get up there as soon as we have it. Want you to know also that next week, next Tuesday, at 2 o'clock Eastern time, that's Eastern U.S. time, we'll have a really special My Moon webcast. We'll be actually talking with Jacob Bleacher, who is one of the NASA Desert Rats down in Arizona, doing part of their lunar analog mission over the next few weeks this month. He's going to do a live webcast from there, not from one of the rovers, but he will be there talking to us about what they're doing. He's going to talk about what it's like to spend a week in the space exploration vehicle, what it's like as a geologist to do that. So that'll be really cool. That'll start at 2 p.m. 2 p.m. Eastern time. Normally we start at 8 p.m., but it'll be a little earlier that day. So go to the My Moon site. You'll see a white poster. You saw Brian's poster there. You'll see Jake's poster there, just to the right of Brian's. That will have the correct information for that. So I want to let you all know about that as well. And then 2 weeks from tonight, on the 15th, we will have Meredith Fields, who is a engineering student at Texas Tech University. She's going to do a webcast talking about, she was one of the winners of NASA's Lunar Art Contest last year. So she's going to talk about her art that she did for that, which is actually a really cool piece that she did. And of course, just 3 nights after that, 3 days after that, September 18th is International Under the Moon Night. So we all wish you clear skies for that. Hopefully everybody gets to see what you want to see. If you have a chance to take part in the contest, we encourage you to do that. I also placed a link to that contest page on the INOM site farther up on the chat box as well. So check that out also. So until then, till we see you again, thank you again for showing it. And thank you again, Brian, very much.
Thank you all very much. Very much enjoyed the evening.
Thank you. So hope to see you all around. Take care.